Hello, geometry students. This is Miss Szymoniak here, delivering you your first flipped lesson of the student teaching section of your geometry class here. And our lesson is going to be like a little bonus lesson at the end of chapter 7 here. I called it solving non-right triangles because we've spent a lot of time this whole chapter looking at right triangles, and as we all know, those are not the only triangles in the world. So we're going to spend some time looking at how we can solve stuff about the other triangles that exist in the world. So anyway, here we go. So I drew a little generic triangle here. Obviously it doesn't have to be a right triangle. And I just wanted to go over how we name the angles and sides. So normally from here on out, we're gonna name our angles with capital letters, and then the sides across from them. So like here's big B. The side across from this angle B is going to also have a B for it, but the sides are gonna have lowercase letters. So you can see I did that with the R and the K here. Another thing is I'm often going to call the angle, if there's an angle and its opposite side, or the side that's across from it, I'm often going to refer to it as an angle side pair. So just so you know, when I say an angle side pair, I mean when an angle and a side of a triangle are across from each other. So just some housekeeping things to keep in mind. And so, as you can tell, if we want to consider all the parts of a triangle, we've got 3 angles, 3 sides to give us 6 total parts. So when we know at least 3 of those parts, and one of them has to be a side, then once we have those conditions met, then we can actually solve the triangle, just like we solved right triangles, meaning that we can find all the remaining angles and sides that we don't know of. And if we want to take a look here, here's a little disclaimer. Knowing 3 angles, so this is where we don't have that one side. So if we know 3 angles, we will not be able to solve the triangle. And if you want to think back to our chapter 6 where we had, when we were looking at similarity and similar figures, we knew that the angle, or otherwise known as angle, when we only know 3 angles, there are actually an infinite number of triangles that can satisfy those measurements. So it doesn't really help to try to solve a triangle when there are infinitely many different triangles that could have those 3 angles. So just a little tidbit there to keep in mind. So that's why we can't use angle. All right, getting into the nitty-gritty here. So when we do have at least 3 parts and one of them is a side, like I said, we can go ahead and try to solve those non-right triangles. And to do that, we're going to use these fancy things called the law of sines and/or the law of cosines. So here is what your book is going to spell out for you. The law of sines just say, so here's the triangle, a new triangle I drew. I've got all my angles labeled with capital letters. Sides are labeled with the lowercase letters of the same letter across from the angle. So I labeled this just like the other one. For our law of sines, all it says is, this one's kind of easy to remember. You can do sine of an angle over its opposite side equals the sine of another angle over its opposite side equals sine of the third angle over its opposite side. And if you remember back to chapter 6, this is another little big proportion here. So we've got 3 ratios that are all equal. So if you want to think of it, just think of it sine of A over A equals sine of B over B equals sine of C over C. All right, so we can use the law of sines. So thinking back to the stuff that we know about a triangle, if we know 3 of those parts, we can use law of sines when we have an angle side pair known. So that would mean we would have to know an angle. We'd also have to know its opposite side, and then our third part can come from anywhere else on the triangle. And just so you know, hint, law of sines is way easier to use. You can probably gander that just by glancing at the formula for law of cosines, and I haven't even talked about it yet, but we do want to use law of sines as much as possible. But in the case where we have to use cosines, that would be when we actually don't have any known parts that are across from each other. So that would mean no matter, if I only have 3 parts known, then that could be like an angle, side, angle, maybe like a side angle side or something like that. So that would be when we don't have any known parts that are across from each other. So that's kind of a worst case scenario. If we do need to use law of cosines, in order to solve the triangle, it's really only needed once. Once we use law of cosines once to find a piece of the triangle, then we can use law of sines to find the remaining parts. And I know this is kind of throwing a lot at you right now, but we'll see. I'm going to go through some examples and we'll see what exactly I mean by all this. But whenever we use law of cosines, the goal is, so if we want to look back up here, the goal is to either get to solve for a side that's across from a known angle or an angle that's across from a known side. So let's say in this triangle up here, I know this side, angle side here. The goal for law of cosines would be to either find angle B, which would be across from this known side, or angle C, which is across from this known side, or side A, which is across from this known angle. Now, just so you know, I do want you guys to memorize these formulas because, hint, hint, your homework quiz for tomorrow, so that way I know you watch this video, is literally just going to be, hey, write down the formula for law of sines, write down the formula for law of cosines. So I tried to color code this to help you remember. So, for example, the a squared here, this is our law of cosine, so the a squared is a side that we would solve for, and then the only angle that shows up is the opposite angle that's over here. So, however you need to memorize that, and then the only other thing you have to deal with are the other two sides that you might know. And so what you do is, those would be in the middle here. And just another quick thing for before we start solving triangles, I want us to be careful with our algebra here because it's really easy to get stuck with algebra on law of cosines. Whenever we're solving, remember to think of cosine of an angle as a number. So when we're solving, we need to treat this as like we've got a squared equals b squared plus c squared minus a number times another number. It's going to be really tempting. I know a lot of you are going to do this. When we have cosine of an angle written down, it's going to be tempting to want to try to solve for this piece first and then leave off this piece and not do our order of operations right. So just a quick heads up. I'll do some more examples tomorrow in class, but just wanted to give you a heads up about that now too. Okay, so getting into some practical stuff. Here's an example where we've got a triangle. We know 3 of the parts, and 1 of them is a side, so we can definitely solve it. And as it turns out, we can actually use law of sines here. So I kind of started the example for you. I'll demonstrate it, and then if you want to, on the next example, I'm going to give you a chance to stop the video and try it yourself. So here, I would start out by setting up my known. So here, I've got to set up a known angle and its opposite side. So I'll start out, I'm thinking sine of A over A equals sine of B over B, whatever. I named my sides with lowercase letters here. So what I did is I started out, I did sine of my known angle over its opposite side equals sine of another known angle over its opposite side. And so this is actually the side that I'm solving for. And so if I do some algebra, I typed this in my calculator, I got 0.05. I did sine of 46, got 0.17. So then to solve for g, remember we're going to times by g to undo that division. So I'm going to times by g over here. So then I got 0.05g equals this. And then we'll divide by 0.05. It's a really bad 0.05, but. And so then I get g to be about 14.93. And so after that, I would have to go ahead and do the same thing to get side E. Because remember, this is not a right triangle, so I can't just use Pythagorean theorem to get the other side. So what I do, and notice I also filled in my other angle. Since I knew 2 angles, I already knew enough to fill in my other angle by subtracting them all from 180. So now here's where I want you to pause the video and try to find E yourself. So go ahead, pause it. All right, now I'm going to show you how to solve it in case you got stuck or whatever. So here's how I'd set it up. So it should look pretty familiar to our last example. Calculator work, so I'm going to solve for E the same way. So times by E, times by E. So we got 0.05E, then divide by 0.05. Divide by 0.05. So E should be about 19.56. And once we've done that step, then you can see that what was this one? I think this was like 14.01. And this was the 19.56. Let me make sure here. Oh, sorry. So this was 0.39. So we got all 6 parts. We solved our triangle. Moving on. Alright, so here's another case where we're going to do law of sines. I've got 2 known sides and then an angle opposite for one of my known sides. So go ahead, pause the video, see if you can try to solve it yourself. Alright, here's how I would set up to solve for angle J. I decided to solve for angle J here, so I used my angle side pair here. And so this would be a case where we're solving for an angle instead of a side. So once I get down to this step here, I'm going to need to get my angle J out, and that's where I'm going to use that sine inverse like we learned the other day. So when I punch that into my calculator, do sine inverse of that 0.66, then I'm going to get about 41.3 degrees. So I go ahead and fill in my 41.3 degrees, and then I can go ahead and fill in my last angle because I can just subtract these two from 180. Now again, remember, we can't use Pythagorean theorem to get this last side. So what I'm going to do is, since I've still got my angle side pair, I'm going to use law of sines again to get my side f. So I encourage you to go ahead and stop the video, try to solve for f on your own here. And so here it is, again, solving it the same way we solved those other ones, times by f, and then divide by 1.64 on both sides, 0.164, sorry. And then we should get about 3.81 for f. 3.81. Oh, there we go. Alright, so I'm kind of speed through here because we've got 2 more examples to get through. Here's a case where we're going to need law of cosines because we know 3 parts, but none of them are across from each other. So I don't have like this angle, or this side, its opposite angles unknown. This side, its opposite angles unknown. And then this angle, its opposite side is unknown. So what are we going to solve for? It's up to you. So the idea is we've got to solve for this angle, and this side somehow. So what one you want to do, it's totally up to you. I just happened to choose, hey, let's solve for the side P. So what I did was I set it up. Now, since I'm solving for side P, P is the one that's going to go in the far left where we saw that a squared thing. So the side, if you're solving for a side, the side that you want to solve for is what's going to go in the a spot. And so then I go ahead and fill in my other 2 sides. This is my b squared, c squared, minus 2 times b times c. And then the angle opposite of the side I'm looking for is going to be what I plug in for my cosine of a. And remember, just think of this as a number. Maybe think of it as like a coefficient times x. So if you need to do that, go ahead. And if you go ahead and do your order of operations here correctly, you'll see that this x happens to be negative 0.57. Now, that negative came about because we did the cosine of an obtuse angle. We haven't really done that yet, but you'll find that when you do trig functions on obtuse angles, you get negative numbers. So if you go ahead and do your algebra, so remember we've got minus a negative product, so then we're going to, minus a negative is going to be adding. And so when we do that, we get 51.1, and then we got to take the square root of it because p is being squared here. So then when we do that, p is going to end up being about 7.1. Okay, so we found one of the sides. Now remember, we used law of cosines only once to get a to solve a triangle. The rest of the time we can use law of sines. So now I'm going to go ahead and solve for one of my missing angles. So I just happened to pick Q. You could have picked R if you wanted. And so I set it up here like this. So I'm looking for Q, which means I'm going to put it over 3. And then now I've got my angle side pair that I need to fill in the other ratio. So if I go ahead and do my math, all I did was I multiplied by 3 here. I'm going to go fast because I'm running out of time. But so if you do that, if you do your order of operations right, and then do your sine inverse of this, then you should get 21.1 degrees. And then once you fill that in, you can get your other angle. And then here's another, now here's the really hard example. And I named it uh-oh because it's a really hard example. So if you want to go ahead and pause the video and try this, I'll go ahead and start up another quick video that will finish this example. And we'll also be sure to practice some in class. tomorrow. So